but they have what they call measures of central location. So the center of the data, kind of like your average or your mean, median, mode, percentiles and quartiles. We'll do a separate day on those, but those are all measures of center of the data. And then measures of variability are like your range. So like not range like you think of on a graph, but like the biggest value, the smallest value. IQR stands for interquartile range. We're going to talk about that today. Variance and standard deviation, those are measures of what they call the spread of the data, like how far are the data values from each other. These are the ones, I think, the measures of variability you probably haven't calculated before in a class. Now, mean, a lot of people like to think of that as the average, but that's just going to say you just add all the values up and divide by how many there are. The median, we're going to calculate these today because there's a couple ways that could look depending on how many data values you have, but it's the middle data value, or it might be an average of 2 if you have an even number. The mode, always taught this is the most often to help remember that, but basically if there's a data value that's repeated, the one that occurs the most number of times. And then the range. The range is, like I was saying a second ago, it's not like range on a graph. It is literally like whatever the biggest data value is minus the smallest data value. That's the range of all the data that you have. So we're just going to calculate these for some data sets today. And this just says these are water temperatures measured in Pensacola, Florida from January to December. So all 12 months. And just kind of the average temperature. Okay, now for calculating the mean, you guys know you're going to want a calculator if you don't have one. We're literally just going to add these numbers up. So just add like 56, 58, just down the line. I'm going to add all 12 of these lovely numbers. Just doing this on the screen, trying to kind of make sure I didn't make any mistakes as I go. I'm just going to run back through that real quick, make sure I didn't mistype anything or forget one. I think I'm good. Okay. Did anybody get anything different? I got 860 when I added all those up. Divide by 12, because there's 12 months in the year there. There's 12 data values, so I'm just going to take and divide that by 12. And then if it doesn't tell you, I'm just going to go ahead and I'm going to round to the nearest tenth here. I'm going to say this is about 71.7 would be the mean or the average. And if you guys notice on my little answer blank over there, if you ever see, they call this X bar, that is just a notation for the mean. So if you see an X, almost like a little line segment symbol over it is what it looks like. They call that X bar. That's a way to abbreviate the mean using a variable. Okay, now can I find the median from the data the way it's written there? What do I have to do? Yes, you have to, yeah, and you can do smallest to largest or largest to smallest, it doesn't matter. I'm just going to start, let's see, the smallest number I see is 56, and I'm just going to kind of, I'm going to cross it out so I don't write it. I see 2 58s, but you do have to write them in order from either least to greatest or greatest to least. Then I see a 63. Then I see a 65. Then I see 71. Then I see a 74. 78, and then let's see, 82, 84, 85, 86. All right, so I just kind of cross those out. Okay, now, how do I actually find the median once I put them in order? That's really horribly not straight. How do I find the median? Do you guys remember how to do this? Yeah. Yep, okay, so that's what I do. So if you have a long data set, sometimes I'll do like 2 at once, like 2 here, or something like that. But yeah, you basically cross 1 out on each end until you get to the middle. And then if I get to the middle and there's 2 numbers, like I have here, what do I do with those two numbers? Exactly. Okay, so if there's two numbers, you just find the average here, or the mean of these two. So if I added those two guys up, if I did 74 plus 71, and we would just divide that by 2, so the average here, this would be 72.5. All right, so I'm going to write that. And not every data set has a mode. It depends on what you have in front of you. Would you say that this data set has a mode? What is it? It's what? Okay, just checking. Yeah, 58. Appears twice. There's two 58s. All the other numbers are just independent. They don't have any others. Now, all you have to do for the range, it's 86 minus 56. It's just the biggest data value minus the smallest data value. So the range of all these different temperatures would be 30 degrees. Okay, now this right here, I'm just going to make a note of this, and this is going to become important in a second, but there are an even number of data values here. Have you guys made box and whiskers plots before? Does that sound okay? Box and whiskers, or a box plot? Does that sound familiar to you at all? Okay, so we're going to talk about quartiles. Okay, quartiles are going to split your data into 4 equal groups. They call them a quartile. The first quartile, sometimes called the lower quartile. This is basically the way you do this, and I'll just do this for the other data set. This is the median of the bottom half. So the lower end, the lower numbers of the data. That's the first quartile. They'll call that Q1, lower quartile, first quartile, or Q1. I'll probably use Q1 because it's less to say. But that's the median of the bottom half of the data. Okay, now I just want to show you what it would be for this data set we just did. So for Q1 here, if you have an even number of data values, you start like down the middle of those two values that we did for the median if you have an even data value. And then I would literally just calculate the median just like we did. Like I would cross one off here, one off here, one off here, one off here. This is further tricky because it's another, I'd have to do the average. But in between those two, I'd do 58, 63, divide that by 2. This would be 60.5. And that would be the Q1. Now, Q2 is actually just the median. So we already did that. So for this data set, the 72.5, that would also qualify as the second quartile or the median. All right, let me find a different color. All right, now, the third quartile, this one is also called the upper quartile. And it's almost the same exact definition. This is the median of the top half of the data. So basically on the right side of the median, if you wrote them from least to greatest. So if you have an even number of data, you literally just look at that median as a dividing line and you would calculate it. So I would do like the 74 to the 86. I'm just crossing these off again. And sometimes you have to do an average, sometimes you don't. In this case, there's 2 numbers in the middle there. This would be a nice number because the average of those 2 would be 83, and that would be your Q3 for that data set. We're going to do an odd data set on the back so I can show you how to calculate that differently here in a second. But what we call a 5-number summary, I'm just going to write these. You have the minimum data value, that'll just be a data value. Then you would have Q1. Then you would have Q2, second quartile median. Then you'd have Q3. And then you would have the maximum. So they call it a 5-number summary. It's the smallest number, the biggest number, and then those values that you would calculate for the quartile. and what we call the interquartile range. These are all just kind of definitions here. The interquartile range is the range of the third and the first. So it's the whatever your Q3 is minus whatever your Q1 is. All right. Now, what we use these for is to turn in, we call it a box and whiskers plot. So that's why I was asking if you guys had maybe ever done that. If not, it's not a big deal. Okay, so I'm going to show you how to do this. And I'm not going to draw this evenly balanced. So I'm just going to draw like a little rectangle and another rectangle, but I'm going to purposely make one a little bit longer than the other. Like they won't be the same length necessarily. And those are the boxes for the box part of that definition. And then on one end, I'm just going to draw like a line segment with a little dot at the end. I'm going to do that little dot at the end on the other. So those little pieces are called the whiskers, the little line segments that come from the end of the box. And this is how you would do this for your data set. This to the far left would be whatever your minimum data point is. Now, this end of the box, that vertical line there, this would be Q1. The vertical line in between those two boxes, that would be Q2. So you basically make a rectangle. We'll do this. I'll have number lines for you guys so we can space this when we try this on the back. And then you would have the Q3 here and your max here. And I'm going to write on this just real quick. The way the quartiles work, they split the data up into four equal, they're not necessarily spaced equally, but represent equal parts of the data. So like the whisker, this is one part, the box is one part, the second box is one part, and the whisker is the third part. The way that these quartiles work, exactly 25% of the data would fall between the minimum and the first quartile. You'd have 25% of your data represented between Q1 and Q2, 25% here, and 25% here. So that's going to measure a little bit how the data is spread out, but each one of those quartiles represents 25% of whatever data that you were given. Is anybody having a question? Okay. Now, I'm going to give you guys an odd number of data values. So we had an even number of data values. This is an odd number. And we're going to calculate these and we're going to draw a little box plot. Okay, so I'm not even going to have you find the average, but this just says compute each statistic, draw a box and whiskers plot, and then round to the nearest tenth if we need to. This just says ages of people in a book club. All right, so the minimum and maximum, these are listed in order, so you don't have to put anything in order here. We're literally just going to grab for minimum and maximum. We can do that in like 2 seconds. The minimum would be 22. The maximum would be 52. The other ones cause us to have to do some work. So I would do the median first. So the median, I'm trying to remember what color I used on the front so I can keep that consistent. So I'm just going to do the median here. So I'm just crossing off. These are in order for you. And in this case, the median, I'm not doing an average or anything like that. The median is one of the data values. So this is the 40. Now, on the last one, I'm just going to flip this back from 1 second to show this to you. When we did it, we had an even number, right? I drew that line down the middle. That was the average. The 71 was part of the calculation when we did the first quartile, and the 74 was part of the calculation when we did the third quartile. If you have an actual data value that is your median, which is what we have here, you are literally just going to like cross that out. That's not involved in either one. And you just do the median of the lower half of the data. You just would do like the 38 and the 22, and you'd go in from there. So the 40 would not be included in either one when you calculate that. And so this is actually nice. This will be 37. And same thing on the upper end. The 40 is not included. You just go right to the side of that. So the 42, and this is actually nice also. This is 47. So it's one of the data values. We don't have to do any averages or anything there. And then we're just going to go through here and draw a little box and whiskers plot. Okay. Each one of these guys on the number line here goes by a 2. So if it's on not a nice number. You can just kind of estimate the best you can. So for the 22, I'm just going to put a little dot above that there. And then for Q1, I would go all the way to 37. So that would be like right between the 36 and the 38. I'm just going to draw a vertical bar there. That's my Q1. And 40 will be my Q2. So right there, little vertical bar. Q3 is 47. So I'm just going to go between the best. Oh, I didn't do a good job with that. Between the 46 and the 48. And then for the 52, I'm just going to do a little dot. Now for the boxes, I'm just going to make rectangles by just connecting the top and the bottom of that with my vertical lines like I drew. It doesn't have to be perfect. And then you just draw a little line segment. It doesn't have to be like directly out of the middle or anything like that. And so that would be my box and whiskers plot. So what I would tell you here, like if you're looking at this, most of the people's ages in this book club, and actually here, let me just write it on here. So this would be 25% of the people, 25% of the people, each one of these little pieces. So most of these people in this book club are older than 37, right? Because if I get to here, here's the 37. So 75% of the people in this book club are older than that. Only 25% are younger. So more of these people are a little bit on the older end. There's fewer people that are younger in this group. And we'll talk about like outliers and things like that a little bit tomorrow, but we're just going to do some basic box plot stuff too today. Now, I'm going to give you a box plot, no data, and you're just going to see if you can tell me these values from looking at the little picture that's provided to you there. So if you're looking at this, and they're not intended, any of them, to be on like nasty numbers or anything like that. They should all be on nice numbers. What would you tell me? This is, let's see. This is representing test scores for a certain class period. So what would you tell me the lowest test score was from this box plot? 55. All right, that's your minimum. What number, and don't pretend it's on a nice value, what number would you tell me for the first quartile? 70. What would you tell me for the median or the second quartile? 75. What would you tell me for the third quartile? 85. And then what was the highest score somebody got on this test? 100%. All right, now you don't have to write this. I'm just going to write it on mine so you can see it. Remember, 25% of the students are going to be in that first little whisker there. And they used a line where I used a dot. You can use whatever you want. But 25% of the people are scoring in that range. 25% are right here in this little box, 25% in this box, and 25% in this whisker. So this says what percentage of the class scored above a 75? 50%. Right, here's your 75, 25, 25. So 50% of the class scored over 75. What percentage of the class scored below a 70? So here's the 70. So just 25, like 1/4 of the class, bless you, scored less than 70. So this would be 25%. Okay, now I've got what they call a double box plot down here, so you can compare two different things on this last example, and then it's just going to ask you a question. So the number line is kind of up above here, and they give you the specific values on the box plot itself. So the first one is for the city of Boston, the second one Seattle. This is just the weather. So it says it shows the average monthly temperatures of Boston and Seattle. So I would say we can pick most of this out of just doing the table. So if Boston's the first one, like the maximum 74, minimum 29, that would be the temperature. The median should be that line right in the middle. So this would be 51.5. The Q1 is the end of the first rectangle on the left, so that'll be the 36.5. And the Q3, the third quartile, is the end of the rectangle on the right, so 66.5. Okay, now I didn't really calculate this on anything, but I kind of mentioned it on the front. The inner quartile range, we call that IQR, is whatever Q3 is minus Q1. So basically it just represents what is the difference between the two sides that make up the rectangle. So all I would do there, we're going to do that 66.5 minus 36.5. So the range, or the interquartile range there would be 30. Now the range in general for the entire data set is just the maximum minus the minimum. So that would just be 74 minus 29. So the range of the entire data set would be 45 degrees for Boston there. Okay, you guys, I'll just do it quietly up here on mine, but you see if you can figure out those values for the Seattle, which is the one that's a little bit further down here. So Seattle's a little bit below the Boston one. And then you guys can, I mean, you can kind of see visually here, right? Boston has a lot bigger range in its temperatures, like it's more spread out. So we have a much, lower low and a little bit higher high, whereas Seattle's are all kind of grouped really close together. There's only a range of 25 different degrees there. All right, so don't have to put this on your table, but I'm just going to remind you, each little piece represents 25% of the data. And then the Seattle one's going to be like really close together. But each quartile represents 25%. That's why it's called a quartile, like 4 quarters in a dollar kind of a thing. So if you're looking at these lovely box plots, I'm just going to look at Seattle for a second. It says, what percentage of Seattle average monthly temperatures are under 52? So if you look at the Seattle one, what percentage of their temperatures are under 52? 50, right? 50%. So there's the right 52 is the median, so you got 50% below that. All right, now let's look at Boston. So that's the one a little bit closer to the number line. What percentage of Boston average monthly temperatures are over 66.5? 25. Perfect. All right, now this says 75% of the monthly average temperatures are above, I'm not on the screen to read this to you, but here it is at the bottom, are above 45 degrees for which city? So would you pick Boston or Seattle for that last question? This is Seattle.